Welcome back to the channel. We have a really exciting lesson for you today. You're gonna learn how to code a weather application. Now, every beginner application developer learns how to do a weather app because it's a great way to learn how to use APIs. But we're gonna do ours with a twist. It's gonna be in the command line. Now, why are we doing this in the command line, you might ask? Well, it's gonna allow us to have some separation between back-end and front-end development. And right now, I want you to understand the underlying mechanisms of Dart so that when you go to apply this same application to Flutter in the future, which we are gonna do, you're gonna understand it way better. When I first had this idea, I thought to myself, this can't be a good idea. Why would anybody want a command line Flutter application? As with most people right now, I have offloaded all of my critical thinking capacity into ChatGPT. So before we do this lesson, let's go ahead and ask ChatGPT, is this a good idea? Is there any value in a command line weather application? Yes, there can be significant value in a command line weather application, depending on the target audience. Let's look at these high-level highlights. Quick and easy access, customization, low resource usage, educational purposes. Ooh, thank you, ChatGPT, for confirming this is a valid educational product. Now that we've used our external brain to confirm that this is a great idea, let's get started with coding this application. Now, I just want to remind you guys that this is actually a very valuable lesson because we're going to learn some really important things. We're going to learn how to use a remote API to pull data. And as you develop more and more, you're going to realize you're not going to want to do everything from scratch. So leveraging remote APIs is probably one of the most valuable skills a modern developer can have. So I'm going to start this video with the assumption that you at least know basic programming, perhaps basic Dart programming. If you don't, we're going to put links to a playlist in the description of this video that will allow you to get up to speed on some of those basics. I'm also going to assume you have basic knowledge of the control flow structures, if statements, for each loops, things like that. And I'm also going to assume you understand the data types in Dart. If you understand all these things, this application is actually going to be relatively easy for you to do, and that's part of the reason it's so dang fun. So before we actually start exploring and writing code, we're going to do something that I like to call pseudocode. Well, a lot of people like to call pseudocode. Now, basically all pseudocode means is you're going to write really high-level code in the English language as opposed to translating it into Dart or whatever language you're working with. Now, there's different ways you can do pseudocode. The first is people will literally just write out statements in English that describe the problem they're having. So you might write, if the giraffe hasn't had enough food, then feed him 10 milligrams of food. In English, you don't worry about code. But then there's an even higher level of pseudocode that I like to work on, which is basically I'll write out the comments of the core functionality and how I see the control flow structure of that app looking. So instead of writing down the really small micro pieces, you take the application at the high level, break it down so that you understand what you're doing architecturally a little more before you actually begin writing code. And then if you want to break it down into that lower level pseudocode, you can do so as well. Our application today is actually fairly simple, so we're going to stick with the high level comment pseudocode structure. As a side note, as language learning models like ChatGPT improve more, or tools like Codex or Copilot, there's a significant probability that you're actually going to be communicating more in English than regular computer code as time goes on, because these models are becoming more and more advanced. So not only are you learning how to architect your application in an intelligent way, you're also going to be learning how to communicate with language learning models in a technical and proficient way. In an effort to save you from the boring process of watching me type for 10 minutes, I've typed up my quote-unquote pseudocode on my own, and I'm going to walk you through it real quick. So first of all, generally my first step when creating a program is to write down my notes and my objectives at the very top. Now, if you're writing a really complex application, you probably want to do this in a text editor or somewhere else or some sort of planning tool. But for this application, I just wrote our notes out up here. Our command line weather application in Dart, what do we need? Very simple. We need data from the user in the format of a zip code, and we're going to capture that through the command line prompt. Easy enough. And we need access to an API that can return data to us and display it to the user. So how you might do this, you might go and look, well, what's a weather API that I can use before you even start the application? So I went ahead and did this for you already, and I found an API called weatherapi.com that's going to provide for all of our needs. Now we have this really high-level basic guideline for our application. We're going to go into our void main function, which remember, in Dart, you have to have a void main function that executes your code. And we're going to write some really high-level code. So let's take a look at this. So we're going to start off the application with a welcome message and prompt to get the zip code. We can't just take any user input, as you might remember from previous videos, because users are going to put in nonsense. They might put in symbols. They might purposely try to break our application. So we need to verify the validity of the zip code data. So what we're going to do is we're going to check, are all the characters numbers? And in the case of a longer zip code, does it have a dash and the additional numbers? We're going to check if that's true, we're going to return valid. If it's not, we're going to issue a warning and prompt the user for their zip code again. So we just need to do a really high-level check to make sure a zip code is accurate. That logically makes sense, really easy to type that out. And then so if the zip code is sanitized and properly formatted, what are we going to do? We're going to go to our application and then connect to the API. Once we've connected to the API, we have to see, is our connection valid? Because as you guys know, sometimes servers are down. Sometimes you might input your wrong API key or the wrong URL to the API. So we need to make sure we have a valid connection. If we have a valid connection, let's get the weather information. And if the weather information is valid, we're going to return it to the user. And if we don't have valid information, we're going to return an error message to the user so they can see what's happening. And if the connection is invalid, we're going to send them a message about that as well. Because we're going to get different messages for server not found versus errors with the API. So we're going to process those a little differently. And in the future, we're really going to talk about error handling more. But for now, we have this really high-level view of our application. If it sounds interesting to you, go ahead and ignore everything I've written and write down your own high-level version of pseudocode. This is a really helpful exercise. So we're going to go back to our void main function and we're going to look at our first heading, welcome message and prompt user to input their zip code. So we're going to print our welcome message. Because I am known as a lead hacker, I'm going to say welcome to Lead Weather, your command line weather expert. That's going to be the first thing the user sees. It's a little funny and cheeky to set the tone for our app and engage users and make them feel right at home. Then we're going to capture our zip code. So I want you to notice something. We've defined a string called zip code. Remember, Dart is an optionally typed language, but where possible, we are going to define that type. And we've created a function, remember it's not a method because we're not using OOP right now, called getZipCode. So let's look at this getZipCode function. We're defining a string called zipcode. Now we're defining it inside of this function because we don't need to use this variable later. And then we're going to have a do-while loop that you might remember from our previous command line applications. So we're going to do getZipCode over and over and over while zip code is empty. So if there's no zip code, we're going to keep executing this loop. And once we get out of that do-while loop, because we have a zip code, we're going to return the zip code. During this lesson, I'm actually intentionally coding things in an organic way as you might actually code it. So as we're going through, you might say, Jeff, that isn't the most efficient way to do things. But here I'm trying to illustrate a concept called refactoring. Often, your first version of code is going to work, but it's not going to be the most efficient and best way you could write the application. So we're intentionally coding things in a way that you can see how a program evolves over time, and so that you don't expect perfection from yourself on your first draft of code, because oftentimes that's not the case. But when you watch YouTube videos or tutorials, you're seeing this perfectly fleshed, perfect version of the application, and you're expecting that that's going to be your experience. Especially as a beginner, it's not. But you do need to develop the ability to look at your code critically after you've written it and say, this is not the best way I could do it. I'm going to refactor this and improve it. So we're running the getZipCode method, and then after we get the zip code, we're printing it out. So let's run a quick test and see if this works. Okay, welcome to Lead Weather, your command line weather expert. Let's enter a zip code. So I want you to notice this is an obvious flaw in the application, but now we can just enter anything. And it will let you enter KFG, blah, 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 blah. Let's enter just a tilde. That works too. So obviously we haven't validated the information. But as you can see, it won't allow us to enter a blank result, which is what we were going for this first step. So let's enter a zip code 80528. You entered zip code 80528. Now let's go back to our pseudocode and see what we need to do next. We need to check, are all the characters but numbers and dashes disallowed? If they are, we're going to return valid. If they are not, we're going to issue a warning to the user and prompt them again. Right now, it makes sense to have this as a separate function. So we're going to create a bool, because this is just a simple true-false return statement called isZipCodeFormatValid. Notice we named this as close to English as we could. And we're going to pass a string called zipcode. Now, as a small note, sometimes you aren't actually going to be dealing with things like zip codes in integers. You're going to be using strings instead. And because read line sync passes a string, we're actually passing a string in here. So we're going to use, again, a regular expression. Now, again, this is beyond the scope of this lesson, but this regular expression does two things. It makes sure that there is a 5-digit number first, and it also optionally allows you to have a 4-digit number afterwards, and it allows either of those situations. If you have either a 5-digit or 9-digit zip code, we're going to return true. If not, we're going to return false. Very simple function. So now that we've created our function to check if the zip code format is valid, how are we going to execute this? You might be saying, let's use another do while loop because that's how we've done it in previous applications. And that makes a lot of sense to me. So we're going to do zip code equals get zip code while zip code format valid is false. You'll notice I indicated false by putting the exclamation point at the front of this function. So what this should do is it should run this function while that's not true. Now this is a little confusing because we've got a do while loop already inside of here, so I can already see that this is something I'm going to want to refactor later, but let's not worry about refactoring for now. Let's get this application tested and see if it's executing the functionality that we desire. We're going to open up our terminal. All right, so we're going to try to enter just random text gibberish again. That doesn't work. So we're going to try to enter a 7-digit number. That doesn't work. We're going to try to enter a 4-digit number. That doesn't work. Let's try 80528. Okay, that works. It let us actually escape from our application. Now let's try a 9-digit number with a dash. That works also. Great, our code is functioning as expected so far. Now that we have our valid 5 or 9-digit zip code, let's move on and do something with that data. So everything up until this point we've accomplished in prior lessons, so this should have been a rather quick review for you. But now we're getting to the meat of this lesson, which is a new concept. This is called an application programming interface. And what this allows you to do is, in a standardized way, access another application. What does this mean in layman's terms? We're going to be able to call to a remote weather program and get data back from it. I mentioned earlier that I had already found a service for us called weatherapi.com. Please pause and take time to fill this out and come back once you have a weatherapi.com account set up. So after you've registered and signed in, you're going to find yourself on this welcome back page, and you're going to see this section here that says API key. Now, Jason, my main man, and Superdog is going to edit out my key, but I want you to take whatever key you have here, click copy, and then return to your IDE. In general, it's going to be considered a quite bad practice to use your API key directly in the code, especially if this code is being deployed to a GitHub or GitLab repository somewhere, and especially if it's a public repository. There's many ways to use API keys in a secure fashion, such as using it as part of an environmental variable on a server. There's other options as well. For our purposes today, we are going to integrate this into our code. I just want you to understand this is not the most secure way of doing things, but for learning purposes, it's fine. We're going to experiment with a config file. This config file is going to allow us to store information about our application in a way that is easily accessible through the rest of our application. So we're going to go and create a folder called conf, which I've already done. And then inside that conf folder, conf, we're going to create a file called conf.dart. For security purposes, I've gone ahead and deleted my API key. You're going to copy and paste yours in here. We're creating something called a singleton. Don't worry too much if you don't understand what that means. Just think of it as a way for us to access one single config class and object that we're going to use throughout our app. There's really no reason for us to create more instances of our config class. To create a singleton, we're going to create a static final variable config, and we're going to use this underscore singleton, and it's going to be config internal. Again, if you don't understand what this means, don't worry about it right now. Then we're going to create a string for our API key, and we're going to copy and paste the API key in there. And then we're going to create two other variables that are also strings called API URL, which is api.weatherapi.com, and then the string root API path. So we're going to do v1/forecast.json. And then we're going to create a factory. A factory is an OOP concept that we're going to talk about more later, but for now, just understand that this is a means for us to implement our singleton. How did I know what these URLs were? One of the most important skills you can have is how to read documentation. So if we go back to weatherapi.com/docs, we can see all of the documentation about this API we're going to be using. So you can see that there's a base URL here called api.weatherapi.com. And then after the base call, there's v1, and then we're going to use any of these APIs. So they have current, forecast, search, history, and a bunch of other functions, which we're not going to use today. I've gone ahead and pre-researched, and for our purposes, forecast.json is the appropriate API for us to use. I've split these up into two variables because that's the way we're going to use the Dart HTTP application to access this server. You'll understand more about that in a moment. Now that we have this config file saved, we're going to go ahead and integrate it into our main application. So before we access and use our config file, we actually need to import it into our main Dart file. Go ahead and do this. It's really easy. You can copy and paste this, or you can just type out conf/conf.dart. So now we're back in our main application. And so if we go down and look at our pseudocode, what did we see is next? The zip code is sanitized and validated at the end of our application. Now we need to connect to the API. So the first thing we're going to need to do before we connect to an HTTP server, we're going to need to format the address that we're connecting to. So if you can see, we're using a URI object, which is an object from Dart that allows us to define a URI with certain parameters. And we're going to call this API URL. So we're going to call this URI, and one of the methods of URI is called HTTPS, which just means it's connecting to a secure server. We're going to use our config object that we created. Since it's a singleton, we can access it in this way. And we're going to do root API URL and root API path. If you want to know why I did this, look at the HTTPS example. You have what's called the authority, which in this case is going to be the domain. And then you have the path that's executed on that domain or authority, which in the example /path in our case is going to be /v1/forecast.json. And then you have here the query parameters which we can pass. So it's kind of the same as web programming, passing query parameters on the URL. We're not going to integrate the query parameters yet, but we are going to call the path here because we want to make sure we can format that properly. And then we're going to print this and see if it looks right. So let's bring up our console. If you can see here, we have https api.weatherapi.com v1 forecast.json. That's correct. Now let's try to open this in a web browser and see what we get. Error code, message API key is invalid or not provided. So the next step is to pass the API key along with this URL. So let's go here to the API Explorer. This is a feature on the weatherapi.com website that's actually going to let you to explore how the API works. So I'm not going to show you my API key here, but we're going to fill out all this information, and down here for the value, we're going to type in a zip code. So we're going to click Show Response, and we can see what the response we're going to get from the API is going to look like with the valid code, but more importantly, we can see what the path looks like. You can see that we access key equals. So the query parameter we need to pass is called key. So we've gone back and we've passed our key. As you might have noticed on the API Explorer, the location for some reason is a key value pair Q. And we've chosen to pass the AQI, which is the air quality index value of no, and we're going to pass days of 1 for now. As you may have noticed, the query parameters are basically just a map or a key value pair. So now we've got our fully formatted API URL, and we're actually going to have to go and access that server. So we haven't done this before. How do we call to a remote server from a Dart application? This functionality is not built into the base library of Dart, but don't worry, the Dart team has developed a package called HTTP that is free, well-maintained, and accessible to all. We're going to show you how to do that now. The first thing we need to do, if you haven't already, is create a file called pubspec.yaml. That's YAML. If you use the Dart create command line application to create your project, this file will already be created for you. If you didn't and you're just creating your Dart files manually, you are going to have to create pubspec.yaml yourself. So what you need to do this, you need to define a name, which is the name of your application. So you're going to define it something like this, weather_app. And then in the description, you can describe it in greater detail. So we have Elite Weather App. And then you have to define the environment. This is the SDK. You can go ahead and just use this for now. Don't worry about it. So now you have this pubspec.yaml file created with the base information required for it to work. You can actually now go to pub.dev/packages, which is the repository for all the Dart packages that are accessible to you. There's a ton on here. Many of them are maintained by the Dart team and are extremely high quality, well supported, good to use. So if you notice, the very first thing we come to the packages page is actually HTTP. We don't even have to search for it. That's pretty awesome. You know this is a great package. By the way, when you're evaluating packages, it's really good to look at the popularity, likes, and pub points to make sure this is still supported. And you also want to make sure this supports all the platforms you're going to want to access. Because as you remember, Flutter is a multi-platform framework. So if you want to deploy to more than one platform and your platform isn't supported here, this package won't work for you. Fortunately, this is supported across every platform Flutter supports. So let's go to HTTP. How do we install it? Let's go to the installation page, and there's two ways you can do it. You'll notice you can run in Dart the command dart pub add HTTP, or you can manually copy and paste the dependencies section. We're going to try the command line option first. Let's see how this works. Dart pub add HTTP. Let's see if it works. So you're going to notice this did something pretty awesome. The first thing it did is it automatically added this dependency code to our pub spec YAML. It did a dart pub get, which actually fetched the latest version of this application. And now we're ready to go. You could also manually copy and paste this dependency into your pub spec YAML if you wanted to. For our purposes today, we'd rather just use the command line application. Our dependency for the Dart HTTP library is now defined. The next step is we need to import this into our application, and we're going to explore a new import version called as HTTP. This means we're going to be able to access this package as HTTP. It's very verbose and easy to understand. So we have our valid API URL here, as we defined earlier. So we're going to print that as a test, and now we're going to define a response object. All this does is it means whatever we get back from the server is going to be saved to our application in a variable called response. So we're going to use our await keyword here. Now, if you remember, that means that we're not going to proceed on to any of the next steps of the application until this code executes. Now, think about this logically. We can't print out the API information unless we already have it. So it's very important to use the await keyword here. As a reminder, in order to use await, you do need to define void main as an async function. So we're going to await HTTP, which again, we've defined our package as HTTP, so we can call it in this method, and we're going to use a get function. And then we're just going to check what this response looks like in our terminal. Let's do it. We're back to our app. We're going to enter a valid zip code, and we're going to look what response we get. Okay, so first of all, you can see that we have our API URL here. We can open it in the browser to make sure it works. Yeah, we're getting a ton of data here. But if you look, when we're printing response, we're getting what's called instance of response. We're not actually seeing the data. I wonder why that is. Fortunately, it's really easy to get around this. We're going to print what is called the response.body. So if you'll notice, when we're accessing this response object, there's a lot of things we can access. We can access body bytes, content length, headers, redirect, persistent connection, reason phrase, request, and status code. We're going to focus primarily on status code and body, but the data that you're getting back from the server that you're actually going to want to use is going to be called body. Now that we have our response.body accessed, let's go ahead and run this code again and see if we get different output in our command line. Excellent. We're seeing all of the information that we saw in the browser in our command line now. But note, it is formatted really poorly. We're going to have to figure out how to access this better. So we've taken a look at the documentation and we've looked at our response body, but there's something very important we forgot to do. We have not checked to see if we have a valid connection to the server. So there's a couple ways to do this. Right now, we're just going to do the most simple and bare bones way, and we'll flesh this out later. We're going to check to see if the response.status code is equal to 200. 200 generally means successful request in the HTTPS world, and that's what they're using in this API. We're going to look at the API docs earlier and look at different response codes, but for right now, we're just going to verify that the response code is 200, and if it is, we're going to print our response body and say this is valid. Otherwise, we're going to say, uh-oh, we have a problem. Time to drown our sorrows in candy. So now that we know we have a valid response, we need to look at that JSON data that we just got. And as you remember when we looked at it in the command line, it's a huge mess. It's really hard to read. So now we're going to jump over to the weather API documentation and we're going to try to look at what we need. So you're going to see here there's the response body. And you can see inside there's a location. There's also a key value pair called current that has a map with all sorts of data about the current conditions. And there's also another key value pair of forecast, which has a map about the forecasted future days. For now, for our first step, we're just going to worry about current. So we've looked at the documentation, and you might know what you need now. But there's another problem we have to solve here before we can actually use that. As I mentioned, we're getting JSON data returned to us from this API. But how do you access this? Dart has this awesome built-in function called jsonDecode. Now please note, before you use this function, you're going to need to import a library in Dart called Dart::convert. This is built-in Dart functionality. You don't need to worry about downloading, but you do need to have this import statement up here. Import Dart::convert. So we're going to have to JSON decode the response body in a way that Flutter can use it as a map or a list or whatever kind of data we're getting returned. Now we just looked at that documentation. If you'll remember, I said there was a lot of key value pairs. And what is a key value pair in Dart called? It's called a map. And so you'll look, I'm creating a map, and we're saying the map, the key is of type string, and the value can be dynamic because we don't necessarily know what we're supposed to be getting back from the API. And I find it easier sometimes, especially when you're testing, to use the dynamic type. And if you want later, you can set a more strict type here. So we've defined a map called JSON data that is a key value pair. So let's go ahead and make sure that this still works and that we're still getting the data that we want to get back now that we've converted it into JSON. Great. It's not going to look much different. The formatting might be slightly different in your command line, but you can see all the information we have is here. So we know that we have a map called JSON data with all the information that we got back from the server. But how do we access this? We are able to access our variable we created called JSON data. We're going to access the JSON data map, and we're going to use the key called location and get whatever the value of that location key is. So let's bring up our terminal. Let's type dart weather app11.dart. Again, that's just my file name. We're going to enter our zip code, and let's see if this output is any different. Oh, you'll notice it's just displaying information about the location. This is so much easier to read. So you can see the name of the city, region, country, latitude and longitude, all that stuff. So what if we want to access something specific like the name itself? Well, we're going to go back to where we're accessing this JSON data variable, and we're going to add on the name key. Let's try it again. So now you see we're accessing just the string Fort Collins. So now we're at the point in our code where we need to stop and think. What information are we actually going to want to return to the user? Because there is a ton of information in this API. Well, I can think of a few things. How about you? Take a moment and pause and see what you think the user might need. So this is what I think the user's going to need. I think they're going to need what the current temperature is in Fahrenheit, because we're in the United States. You can do Celsius if you're elsewhere, if you prefer that. I think we're going to need what the weather feels like, because based on humidity and wind chill, the temperature and what the weather feels like can be very different. That sounds super useful to me. Let's also return the humidity, because that's something that people want to know, and perhaps the wind speed. Now keep in mind, if there's other things that you want to know, you can go to the documentation and look if this information is available and how to access it. And you can actually improve your application and make it better than the one that we're making. Feel free to do so. You are always encouraged to customize these applications and improve upon them or change the design. So now that we know what we want to call, how are we going to do it? Let's jump back to our code and see. So if you remember, we accessed the name of the city by going into the JSON data, the key location, and inside of that key, another key named name. Great. How do we access the temperature? Well, if you look at the documentation, which I've done ahead of time, you can go ahead and see that there's another key called current. And inside of current is a key called temperature_F for Fahrenheit. And there's also in current a feels like _F. Great, these are super easy to access. Now, I don't know about you, but on command line applications, I hate when the lines wrap and are too long. It makes it hard to read. So I'm going to end our print statement here and go down and issue a second print statement for the wind speed and the humidity. It's actually very easy to access these two pieces of data as well. We're going to access the current key, humidity key in JSON data, and we're going to access the current key once more in the wind MPH key. Feel free to change this text in any way you see fit. I've written out how I want to see it in my command line, but this is your application. So we need to go ahead and test and see if we're getting the correct information. All right, we're going to enter our zip code, 80528. Oh, wow, we've got some data here. Oh, you'll notice I have the API URL printing here for some reason. That was from a previous test. I'm going to take that out. One of the things about code is if you use print statements to debug, you're going to find yourself leaving those print statements in your program accidentally sometimes, so make sure to delete them. In the future, we're going to learn how to use debugging tools to reduce or eliminate the use of print statements. For now, just be sure to double check that you don't have extraneous print statements that you don't need. So let's go ahead and delete that. Now let's run this one more time and see what happens. Okay, so you can see that we're still printing out the JSON object. Gosh, we've got to delete that too. Where is it located? All right, here we are. Let's delete that. Now let's test the application one more time. This looks great. You enter the zip code 80528. In Fort Collins, the temperature is currently 34.0, but feels like 25.9. The humidity is 85 and the wind is blowing 6.9 miles per hour. It's looking great. This is actually kind of a useful application. I've noticed one small little thing. I'd rather have the Fahrenheit abbreviation after the temperatures. I think that makes it look a little nicer. And you know what? While we're at it, why don't we put a % after humidity? We've already got miles per hour after the wind speed. Let's test it one more time. Looks great. That's easier to read. Now I want to point something out. Remember earlier we asked if a command line application makes sense? Think about how nice it would be when you're working on code if you had a shortcut or an easy way to run this application without having to go and open up a widget on your sidebar or open up a third-party website. This could actually be a really handy way to access information quickly and easily. Command line applications are great when you're a programmer. However, I can think of some ways that we could probably improve this. Wouldn't it be more useful to see the weather forecast for perhaps the next 3, 7, 14 days? I know that there's a way for us to do this because I looked at the documentation earlier, but let's go ahead and check the documentation for ourselves. Now, if you recall earlier, I said there was a key called current, but because we're using the forecast.json API, there's also a key called forecast. And look at that. Inside of the forecast key, there's also another key called forecast day, which has an array inside of it or a list. This is defined by the brackets. Remember, a list in Dart has brackets, whereas a map has curly braces. So that means that inside of this forecast day index, there is a list of dates. Let's pull this data from our JSON data variable. It's actually pretty easy to do. There is a key called forecast, and inside of that, there is another key called forecast day, which contains a list. So let's define a list of dynamic type and call it daily forecast. Because remember, we want to be able to access all of these great built-in tools that Dart has. And then we're going to just look at this data. We're going to do daily forecast. And for each daily forecast, we're going to print the forecast variable that we've defined here. So you can see we're going to enter our zip code like normal, and then we're getting a bunch of data. But this data still isn't really useful. How can we narrow it down just to the things we need? Earlier we talked about writing down what information we need. Well, I think we need to do that again for this map. So let's go ahead in our code and in the comments so it's easily accessible, let's write the things that we need out of this list of forecasts. Well, the first thing we're going to want to see is we're going to see the name of the day, like Monday, Tuesday, Wednesday, Thursday. We're going to want to see the high and the low for that day. And I think we're going to want to see the conditions because this weather API returns to us a string called conditions, which will say something like partly cloudy. That's really useful. And then let's see how we'd access this in the API in a usable way. Now, please note, I found all this information by looking through the documentation, and this is why I recommend you look through the documentation and see what all is available. So we can see the high would be our forecast variable here, and then we're going to access the key day, and inside of the day, we're going to access max temp. Forecast is going to be day again, min temp. And then forecast has a key called condition, and inside of there is a condition called text. We're going to prepare a print statement for the forecast in the same way we did for the current conditions. So we're going to say on day name. Now you'll notice I'm writing out day name here. There's a reason for this. The name of the day does not come as part of the API, and we're going to have to calculate that ourselves. But for now, we're not going to worry about that. So we're going to do forecast list day temp. And remember, I've added the Fahrenheit here. We're going to say forecast day min temp, and we're also going to do the conditions, just in the same way we listed them out before. Let's go ahead and test and see how this looks. Let's enter our zip code. Oh, this is amazing. Look at this. You can see on day name, the high will be 38.3. You can see the low, and you can see the conditions. I love the conditions. Overcast, partly cloudy, patchy with light snow, moderate or heavy showers, heavy snow, heavy snow. That's wonderful. Now you'll notice the main flaw here is that we just can't see the name of the day, so right now it's not useful. So what options do we have? So the first option we have is just to use that date, listed out in the year, month, day format. Let's try that. I personally think that's kind of ugly. I wouldn't want to use that for my application. I think it's harder to read, but it's an easy and quick way to get it accomplished. So you can see on 2023-03-10, the high will be 29.8. I don't like that. I think we can do better. If you prefer that format, feel free to stop here. But I'm not going to tolerate anything less than perfection. So in order to format the dates in the way we want, we're going to use some functionality that once again is part of Dart. It is part of a package that you have to download in the same way that we downloaded the HTTP package. So let's go ahead and do that real quick. Now, since we've already created our pubspec.yaml, this is so crazy easy. There's a package called intl, which stands for international. It's meant for converting time zones and things of that nature, but it also allows you to format dates. So if you look here, we're going to go to the installing tab. Remember, it's Dart pub add international. Very, very easy. We're going to paste it into our command line, run enter. It's added to our pubspec YAML file, and it's also running Dart pubget to fetch it into our application folder. And then you're going to need to add the import statement to the top of your Dart file. Easy peasy. So if you notice here, we're on pub.dev, and there is something on the right sidebar that says API reference. So this is what we're going to look at. Now, if you'll notice, we're looking for something for formatting DateTime. Let's scroll down until we see something that's useful for us. Oh, here we are. Date formatting and parsing. So you can see it actually uses some examples here, and one of them actually shows a date like Wednesday. So the important thing is to notice that there's this EEEEE format code. These are really bizarre. I don't know why it's set this way, but EEEEE gets us the date in the day format, in the name, like Wednesday, Tuesday, Monday that we need. So now let's go ahead and notice something else. It's saying a date time. So that means we need a date time object from Dart in order to use this. So we're creating a date time object called forecast date. And into that datetime object, we're passing datetime.parse, which just means it's going to take a string and turn it into the object for that forecast date key. And then we're going to use our date format class that we just imported. So we're going to call this day of week. Now remember, we need to use that random formatting code EEEEE.format, the format method. We're going to pass the date time object into it that we just created, and we're going to say toString. Now, a lot of times there's data you're going to have, whether an integer or a double, and you're going to want to print it or manipulate it not as a number or a datetime object in this case, but as a string. So we need to add the .toString method to make sure we're using it in a way that we can access it. In our print statement, we're going to replace forecast date with day of week. This is pretty simple. I understand it might feel a little convoluted. Working with dates, honestly, is a little confusing the first few times you do it. But I would challenge you to experiment on your own, maybe try to convert this into a different format and use the documentation to do so. But for now, we have what we need. Let's go ahead and run our file. Wow, you can see we've got our current weather forecast, and you can see we've got a weather forecast for the next 7 days. Now, one small note, you might be asking, how did you define 7 days? Well, if you remember in our code where we set up this URI object up here, we had a key value pair passed with our query parameters called days7. You can change this to whatever you want. Let's just change it to 14 and see what happens. Fantastic, look at this. We can see 14 days into the future. This is amazing. Bad note, I see a lot of snow coming in my future. Oh boy. This is actually really cool and useful. I am absolutely positive you have noticed some issues here with the design and implementation of this application. Believe it or not, this is intentional because, as I mentioned before, we want to start learning how to refactor our code or redo our code in a better way. First, there's definitely some code in this application that could be designed in a more modular fashion. We didn't use as many functions as I would have liked. This is a very simple application. And so while modular code is not an absolute necessity, you still need to get into the practice of thinking about architecting your applications intelligently, small or large. The second thing, we are not really validating the data that comes back from the API. And we're not really handling error checking in a way that I find suitable. So we need to also explore how to error check further. We're going to come back in future videos and we're going to explore how to do these concepts with the weather application we just wrote. So stay tuned, come back, and we're going to improve this and make it even better.